Hello all, in today's video we'll see how to draw an use case diagram. Use case diagram consists of four things: the system and the actor, use case, then the relationship between the actor and use case, which is of four types: association, include, extend and generalization. We'll see the four things one by one. System, which could be of a website or a software component or the business process or an application, whatever may be, for which application we are going to draw an use case diagram is considered as a system. For example, I'm going to consider the e-banking application, maybe of Google Pay or Phone Pay, anything, a kind of banking app. We are going to draw an use case diagram. So my system is banking app. The notation to be represented is a boundary. This is known as a system boundary. A rectangle is a system boundary. At the top of the rectangle, which means inside the rectangle, we have to write the system name. Then actor. Actor is of three types: primary actor, supporting actor and offstage actor. Primary actor has a goals. It can be fulfilled through using the service of the system. Primary actor is nothing but who initiates the particular operation is the primary actor. Supporting actor provides a service to the system. He will not initiate any of the actions. For a primary actor, if suppose a primary actor initiates an action, the supporting actor will provide a service for it. For example, if the primary actor is a customer initiates the payment and the bank provides the services. So primary actor is customer, supporting actor is bank. If the customer doesn't initiate the payment, then there is no need of the supporting service. Then offstage actor, they have an interest in use case, they are not primary or supporting. For example, government tax agencies. For example, assume we are going to create a use case diagram for a billing system in any supermarket. The cashier initiates the billing process, so the primary actor is cashier, and the supporting actor may be the payment authorization service. If the customer want to pay a bill through online payment means we need of payment authorization service, so the supporting actor could be of payment authorization service. The government tax agency, for the generated bill as well as for making the online payment, how much tax is the customer has to be paid, which will be calculated by government tax agency or tax agency policies, right? So this is an offstage actor. So these are the three types of actors. The actor symbol, the notation to represent the actor is the stickman symbol. So in the e-banking application, we are having two customers, two actors, one is customer, another one is bank. Whoever the primary actor gone this side, the secondary actor will be drawn right side of this use case diagram. Primary actor will be drawn in left side of this diagram and the secondary actor will be drawn, or the supporting actor will be drawn in right side of the use case diagram. Offstage actor will also go here, and there is no constraint that there should be only one primary actor, only one secondary actor. We can have n number of actors depending upon the problem. Then use case. First we should know what is use case before drawing the use case diagram. Use cases are the text stories of some actor using the system to meet out the goals. So they are a textual representation, so we can call it as a text stories. Okay, how to name a use case? We have certain rules. It should be of a verb format. Here we have quoted an example. If the user want to buy pizza means we should write buy pizza, not pizza ordering. Those kinds of word is strictly not allowed. We should start with active verbs. Okay, let me say some other example like make payment, process sale, handle returns, book ticket. The first word should be of verb and then followed by the noun or object. In e-banking application, the possible operations are login, check balance, transfer funds, make payment. Yes, we'll first log into the application. We can check the balance and then we can transfer funds from one account to another account, and we can use the e-banking app to make payment. We can pay any of the bills through banking services, right? So these are the possible operations. For a use case diagram, we should think of what are all the possible operations an actor can do with the system and primary actor can do with the systems. Those actions can be considered as use cases, and the use cases are represented using oval symbol. This oval symbol, inside the oval symbol we can represent the use case name. So banking application is a system boundary. We have customer, bank as an actor, and the possible operations the customer can do with the banking app is login, check balance, transfer fund, make payment. Note that all the first word of this use cases are the verb. Login is the action verb, and check is a verb, transfer is a verb, make is a verb. So we should start our use case with a verb and it is represented inside the oval symbol. So we have 4 use cases and 2 actors in our system. The last one is relationship. As I said already, we have 4 types of relationship in use case diagram: association, include, extend, and generalization. Association means we are going to connect the actor with the use cases. If the customer relates to login means we have to put a solid line between the customer and the use case. So usually the primary actor may have the association relation with every use cases. Customer have an association with check balance. Customer is related to transfer funds. Customer is related to make payment. But this bank is not related with login, right? For example, whenever we log into the GPay, we forget our e-pin means bank will not generate any of the messages from us. So message to us. So bank is not related to login, but bank is related to check balance. Bank relates with transfer funds. Bank relates with make payments. So we have represented the association. Next we are going to see include, extend, and generalization in this. I have additionally represented 5 use cases here. The use case name is verify password, display login error, verify sufficient funds, pay from savings, pay from checking. Okay. Here, see, whenever the login use case is executed, the verify password will also be executed, right? For assume you are giving a username and password in any of the applications. Whatever the password you have given will be checked with the database, and the result will be either login successful or login error. So whenever the login use case is executed, verify password use case will also be executed. This is base use case. This is dependent use case. This use case is depend on the login use case. So if a base use case is executed, always a dependent use case will be executed, means then the relationship is include. But display login error will not be always executed, right? If we give a correct username and password, then we will log in to the home page or will get a login successful message. Display login error is not always executed. In this case, it will be executed or it may not be executed. This relationship is known as extend relationship. Okay, here login is a base use case, verify password and display login error are dependent use case. So whenever the base use case is executed, the dependent use case will be executed, means then it is include. Whenever the base use case is executed, the dependent use case may or may not be executed is known as extend. Okay, now come to this third type, third use case, verify sufficient funds. So we have to check, the bank has to check whether the customer has a sufficient funds to make transfer funds or not. Okay, so in order to transfer fund from one account to another account, we have to check the sufficient. For example, if we have an 10,000, if we have an amount of 10,000 in our account, but if we try to make transfer fund to my friend with 15,000 means, then it is not possible. So verify sufficient funds. So whenever the transfer fund happens, the verify sufficient fund use case will be executed. So this relationship is, yes, include relationship. Okay, now come to this last part, make payment. Make payment, we can make payment from our savings account or current account. Okay, assume it is current account, we may have different types of account. So pay from savings, pay from checking. So this is a kind of generalization. If you are aware of Java programming or any of the OOPS concept, you may have heard of inheritance. So a superclass with subclass, so similar to that, we'll call it as a generalization. So make payment, pay from current, pay from savings. So both relates to payment, it is one type of payment. So this is known as generalization. So the notation is, we have to represent dotted arrow with stereotype include. Dotted arrow, inside it we have represented include. Similarly, the include is from base use case to dependent use case, but extend is from dependent use case to base use case. The arrow is from base use case to dependent use case. Inside the arrow we have to write extend. I think it is not clear, but try to understand. From base use case to dependent use case, include. From dependent use case to base use case, it is extend. And for generalization, we will use this hollow triangle representation from the superclass to subclass. Okay, so 4 types of relationship. Normal stick arrow is association, dotted arrow from base to dependent is include, not dotted arrow from dependent to base is extend, and hollow triangle arrow from superclass to subclass is known as generalization. So this is the overall diagram for the e-banking application. Thank you all.